Hello, everybody. Now I will introduce our next speaker, Roland Rau, who is a professor of demography at the University of Rostock, where he currently serves as chair of the Department of Sociology and Demography. In addition, he is a senior research scientist at the Max Planck Institute for Demographic Research, and his main research interests are mathematical and statistical demography, survival improvements in developed countries, and population aging. So thank you for being here today, Professor Rowe.
Thank you very much for the kind introduction. Yes, and I love demography. That's maybe my third occupation or my main occupation for more than 25 years. I will try to share the screen. Can you see it well?
Yes. Yes.
So the title of my talk is Addressing Policy Questions with Formal Demography with Examples in R. If I'm hard to understand or something, please let me know immediately. I started learning about demography by accident. I don't want to go into the story, but just by accident, I attended lectures on formal demography, population dynamics, and that really got me hooked. It was 96, 97, the winter term, University of Bamberg. And I wanted to work in this field. So I started out on the 15th of June, 2001 at the Max Planck Institute as a doctoral student. And just 2 weeks later, Ron Lee published his famous paper, Demography Abandons Its Core. So of course, this is not a causation when I start becoming a demographer that demography abandons its core. But what I thought was very interesting in this paper, is just a few pages long. I guess many of you have read it. It's still available on the web, is that most important questions for demography and most important questions maybe for public policy in general, are macro questions. And if they relate to demography, formal demography could be a tool to address those questions. I hope I summarized some main point of the paper correctly, since Ron Lee is also present in the audience. So that's something I was curious initially. I was just interested in, well, this is so exciting to learn so much about population dynamics, the stable population model. But I thought it was very, very inspiring what Ron wrote, and I was like Annette in Jim Vopel's lab, and it was mandatory reading in the second, third, or fourth months for the whole lab to read about it. And it's still in me, the paper. However, I see relatively little work actually how formal demography can help to address policy questions. I don't want to say answer policy questions. It's just one piece to help maybe answering such questions. I have 3 goals for my presentation. Number 1, addressing policy questions with formal demography. Second, I want to present some software which I wrote to try to answer those questions. So having this deadline today really pushed me to go ahead and finish those packages finally. And hopefully I can also show that formal demography is fun, because if you don't have any fun doing something, well, it's boring and it's tedious and it's not so, it's not fun. And then, you don't work in this area anymore. But I think more demographers should work in this area. And I'm very happy to see, I think, about 50 participants in this course. So this is really great. What we want to use is the toolbox for today's stable population theory. And at the end of, or almost at the end of this week, I guess everyone or almost everyone has heard about stable population theory and some characteristics, some parameters you can estimate within this setting. What are the assumptions? And this is usually the criticism. For instance, age-specific but time-invariant fertility and mortality. So age-specific mortality doesn't change over time. Age-specific fertility doesn't change over time. You have no migration, and it's a female-only perspective on populations. And the question is, isn't this quite unrealistic? And I don't know who invented this kind of image originally, like with the tachometer, how fast you're going by car. And I put this picture there on the right-hand side. It's I modified it slightly, which is allowed by this license. Even if you say, well, I'm going 80 miles or something, it doesn't mean that you have to go 80 miles. You don't have to drive for an hour. You don't have to go for 80 miles. It still gives you some information about the inherent dynamics of your car. Or if we look at populations, about the inherent population dynamics, if fertility and mortality do not remain, if fertility and mortality remain constant over time. Of course, that's a typo with the not. So like you're driving a car, you go 80, you go 100, and still, even if you don't go 100 kilometers or miles, still it gives you some information about like the dynamics, about the momentum of the car. So I hope most of you are familiar with stable population theory. And the example I want to give is a bit out of my usual playing field because I'm not working in fertility research, as you know, or just have heard. But this is, I thought that's a good example, maybe how formal demography could help not be the only tool, but help asking questions whether the introduction of the Elterngeld, the parental allowance in Germany, is a success, was a success or not. For those of you who are unfamiliar, there's a few people from Germany or who lived in Germany like Josh, so you're familiar with it. It has been introduced in 2007. It's a financial transfer. You get about 2/3 of your last net income, a minimum of 300 euros, a maximum of 1,800 euros, limited to 12 months or 14 months if both partners participate in this kind of like staying at home with the child. And there were many modifications over time, changes over time, but I hope you get the main idea. You get about 2/3 of your last net income within some brackets. There are many goals, and like what Martin Bujar wrote in 2013, he identified 5 goals, like more time for the family, increase labor force participation, and so on. And increasing the fertility rate was just one of the goals. So we focus on the increasing fertility rate because there were also some reports written for the federal government in Germany saying, well, this is important also for our future, for our pay-as-you-go system for pensions. So we only look at one aspect, and it's only one tool for one goal. So what we do is not a real comprehensive policy analysis. What I want to present to you here now is this is the situation which is usually or often discussed in the media. They don't look at the fertility rate, but they look at the number of births. And what they saw for Germany from 1990, so time of reunification on the left panel, until 2006, a steady decline in birth. The patterns are slightly different in East and West. And for those of you who don't know the relations of the population sizes, the East is about like 1/4 of Germany's population, and Germany West is about 3/4. That's why the main trend on the left-hand side is driven by the trend in Germany, in West Germany, former Federal Republic of Germany, with this declining trend of birth. Germany East, so the former GDR, the birth stabilized somehow at about the year 2000 after this dramatic drop in 1992, 1993. But I don't want to talk about this, but rather about the future, what will happen afterwards. Let's introduce Elterngeld, this parental allowance. But first, let's look at the fertility rate. This doesn't look so dramatic. We have the drop in East Germany going back to about a level of 1.3, 1.4. And if you look at Germany combined or Germany West, this kind of bouncing around between 1.3 and 1.4 has been going on since the early 1970s. And let's make it a little bit interactive. The question I want to ask you is, how long does it take until the policy reform takes effect? So we want to analyze how long does it take that we see some kind of recovery, an increase in the fertility rate? What do you think? Who's not so shy and gives me a number? Preferably not those who live in Germany or lived in Germany, because maybe then you know what was happening. Was it maybe an immediate response because all the people were postponing their births? There's this literature about, yeah, tempo and quantum of fertility, that many women were postponing birth. So do they finally say, now let's have a baby? We were waiting already for it for 5 years. Or is it rather a slow effect? What do you think should we, when do you think we should look at the policy has taken some effect? Should it be like 1 year, 2 years, 5 years, 10 years? Who has an idea? Who wants to suggest something? So what I would like to hear is a year, or like it takes 5 years. It should be visible already after 1 year, because if it has an effect, all the delay should be like put, all the people who were delaying, postponing their birth want to have a baby now in the first or second year. Who gives me a number? Because this will be also the number we'll be using for the remainder when we actually work a little bit with R.
We are having some answers in the chat between
Okay.
1, 2, and 5 years.
What would you recommend as the host?
I think we can call on some people who is telling some years and ask them what they think.
Sure, yes.
Mia, why do you think 2 years is a good number?
I was just thinking that after seeing the policy, people want to think about it, evaluate, and because births take the time of pregnancy to happen, so around 2 years we might see the effect. So some time of thinking and then some time of waiting before birth.
Good idea. I was hoping that someone says 5 years, because that's what I prepared, but we will do some live coding, so it doesn't matter. So would you say then 2008 or 2009? Because then 2009 would be 2 full years, maybe. Would this be a good idea?
Okay, yeah, we can do 2009. Sure.
So 2009. This will be a bit of like, yeah, live coding, and hopefully I don't make too many mistakes. It's been a long day so far in the office. It's like, yeah, 7 p.m. and I arrived in the office at like 8:15 this morning. But I'm pumped and looking forward, hopefully, to give a nice rest of the presentation. And please let me emphasize again, this is not a real comprehensive policy analysis. Anyone who has taken some courses on evaluating policies knows we only look at one goal. We disregard any financial aspects. We don't look at any kind of causality or other contributing factors. Any change we see, we would attribute to this single policy effect. So this is a super extremely simplification of the actually underlying or of a comprehensive policy analysis. So I selected the year 2011 to prepare my slides, but that's not what we're doing now, because we picked the year 2009. And so I can show you maybe already what has happened. So there's a recovery in birth, and it's a bit strange because like after, let's say, slightly more than 1 year, when they published the numbers, they already said this is an effect of the policy, not thinking that maybe births take about 9 months to take place after a policy comes into effect. Of course, you can anticipate a little bit. And as demographers, as formal demographers, we know that numbers of births are heavily influenced not only by the age-specific fertility rates, but also by the cohort sizes of women at childbearing ages. What we see, if we look at the total fertility rate, we were here, maybe you can see the mouse cursor in 2006, and there was a slight upward trend for East Germany, but not much change until 2009, or also for the subsequent years until 2012 or 13 in the total fertility rate. How can we use formal demography? And now this is the experiment I'm doing. I did a screen share. Can you see this gray background now?
Yes.
So this is a special request from Josh. At least that's how I understood it. Not using RStudio, but our favorite editor, Emacs, to advertise some old school tool. You have two parts of the screen. The upper part is this is where you write your code, and the lower part is this is where you evaluate your code. So similar to RStudio, but maybe interesting for those of you who have no experience with other environments. And I still love Emacs because it's super customizable, and yeah, it's my favorite tool on the computer. So I wrote a few packages, and the packages are all on GitLab. The reason is that I load the main package. It's called stable pop, and I hope you can see me. I prepared a handout which I will distribute afterwards, which is also some kind of user guide for all those 4 packages. So you have hopefully some nice things to work with. The package is called stable pop because it's for stable populations. And it loads 4 additional packages. So number 1 obstacle is already, okay, I did this already. We have 4 packages. I hope you can read this as well, or is it too small? Should I make it larger?
I think it looks okay. I don't know for the rest.
If there's someone saying make it larger, please let me know. That's not difficult to do. So there are 4 packages. Number 1 is annual world population. This gives the world population from 1950 until 2100 in single years and single age years from the United Nations World Population Prospects. And that's the reason why everything is not on CRAN. This is or CRAN, the R archive network, because this has a very strange license, which is not really permissible with R. So that's why I went with CRAN. That's why I uploaded it to GitLab, and the others are dependent on it. World Pop Query is the possibility to select data from the annual world population, so from the United Nations World Population Prospects, and HMD, HFD Plus. This is something by Tim Rife, which most of you probably know. This is the package to access data from the human fertility and human mortality database. And I prepared a package which contains data for projection matrices, but the raw data. So I guess you understand what I mean with it. What we wanted to do as a comparison was we wanted to look at Germany in 2006, and hopefully this works. The function is called stable pop HMD HFD. The country is, for those of you who have worked with the human mortality or fertility database, they have sometimes not those ISO codes. So this is Germany, the national population. We picked the year 2006. The HMD user password is my HMD user. I prepared this, of course, and I don't want to present in the public my passwords, of course, as you can understand. HFD password, and hopefully this works. Sometimes there are some issues, and maybe you saw the announcement that the human mortality database wants to change its interface. So it will work this week, but maybe not for much longer. Hopefully the internal structure doesn't change too much. This is already, maybe your username or password are off. No, that should be okay. So this is not very good. Let me, what did I do wrong? HMD.
Roland, I think your last line, the HFD password.
Copy paste issue. This looks better, but at least there's no mistake yet. Thank you very much. This looks good, and we do the same thing for not 2011 as I prepared in my code, but we have expert knowledge here. And we were told, no, we should see an effect already by 2009. This looks good. So we can have a look at the structure of what the code does automatically for you. Apart from downloading those data, you get a list back of many, many different components. So it gives you back the projection matrix, so the Leslie matrix. Then we have the projection matrix for the momentum case. So when fertility is switched instantaneously to a net reproduction rate of 1, the growth rate, so the intrinsic growth rate, or if you look at matrices, this is the dominant eigenvalue. Age structure now is the current age structure, which we observe here in the year 2006. Age structure stable is the stable age structure, so the right eigenvector in relation to the dominant eigenvalue. And age structure momentum, this is the age structure in the momentum case, which will eventually be achieved. Few others, the net reproduction rate, the generation length T, M bar. So this is the mean, the arithmetic mean, the mean age of the age-specific fertility rates. This is the comparison to the official estimate from the Human Fertility Database, which can be also downloaded to see. This is not important for our rest of the presentation, but this is rather a check whether my estimate and my code is close to what the official estimate is doing. And you see we have a value of 29.6, 29.6. Mu1, this is the mean age at childbearing in a stationary population. A bar is the mean age at childbearing in the stable population, which is in a shrinking population is always larger than mu1. I use the notation from Hal Caswell's book in case you wonder. EX, remaining life expectancy at age 0, 1, and so on. Life expectancy at birth. Then we have something, if you talked in this course about perturbation analysis, Hal Caswell's book has some suggestions to look at the sensitivity to changes. How sensitive is the growth rate to changes in fertility and mortality? So we have the sensitivity matrix, which looks at absolute changes. So if you change fertility and or mortality by an absolute amount, and the elasticity, so this looks at proportional changes, Fisher's reproductive value, and using the analytic equation of Sam Preston and Michel Guillot to estimate population momentum, then a brute force version and a recursive version. I like to do this sometimes, but sometimes it doesn't work, but it's intellectually nice and challenging to write recursive functions. And this is rather for debugging in the end, how many recursive calls were required to find the stopping condition. The same elements are, of course, there for Germany 2009. So let's see. We cannot look at the total fertility rate because we are in a stable population model, which only looks at female birth. That's why it makes probably more sense to look at the net reproduction rate. So this would be Germany 06 NRR. This is a demonstration. Maybe you find this code also useful for your own work in the future. It's of course published under a free license. Oh, not 11, of course, we have 09, sorry. So actually the changes I bring back from 2006 until 2009, there was not much change in total fertility rate. And we shouldn't be surprised, therefore, to see very little change in the net reproduction rate. Will it affect the long-term growth rate might be another question. So this is the dominant eigenvalue, or the famous Lotkas R, I think it's also called. So instead of the net reproduction rate, I called it growth rate. We know that Germany is shrinking if there's no migration. Will it affect the growth rate of the population? Yes, it does. But as you can see, the difference is rather minor. So 0.985, 0.986. So this is like a 0.1% change in the growth rate or in the shrinking rate. So this is rather little. What we can see, or maybe what's interesting is if we look at the population momentum, maybe you saw it already. Germany 06 momentum, Preston Guillot, they always yield the same results. So what does this mean? You have a value of 0.83. This is, I'm not sure whether everyone is familiar with the population momentum. I like the paper. I presented it a few months ago as my favorite formal demographic paper, the one by Sam Preston and Michel Guillot, where they present an analytic equation for the estimation of the population momentum for any kind of population, not just stable populations. And so the population momentum measures, for those of you who are not familiar with it, by how much would the population still grow or still shrink if we changed fertility, if we switched fertility from one moment to the next, from 1 year to the next, to the replacement level, so to the net reproduction rate, to a net reproduction rate of 1. Surprisingly, it doesn't become stationary immediately. It takes a while, and the ratio of the final population size to the starting population size, this is what's called momentum. And what we see here is a value of 0.836. So that means even in the absence of migration, even if Germany was able to switch in 2006 from the given fertility levels to a net reproduction rate of 1 in 2007, because the policy is such a great effect, the population would still shrink by more than 16%. The question is now, not the question, but we can also look at it now, how it has changed, how it changed over time. We see that the population growth rate, so the lambda 1, the dominant eigenvalue, has slightly increased in those 3 years. And now one of the surprising things, at least for the 2011 data which I looked at, sorry. That's quite surprising, no? We see an increase in the fertility rate, in the net reproduction rate, in the long-term growth rate, but within those 3 years, Germany's age structure has aged so much more that actually the aging effect is stronger, and Germany would then go down to a level of about 82%, so shrink by 18%. So that's 1.5 percentage points more, which I thought was quite surprising. Despite fertility going up, the population momentum still became smaller. Another concern is, of course, how will it affect pensions? And Germany has, as many other countries, a pay-as-you-go pension system, and we are in the process of increasing the retirement age from 65 to 67. Nevertheless, one of those standard indicators to estimate aging in a society is the old age dependency ratio, which most of you probably know. So that's the population age 65 and above, potential people at retirement ages, divided by those at working ages, and usually those are the ages 15 to 64. We can look at the old age dependency ratio now, let's say in 2006. What is this? This is Germany, 2006, age structure now. And if we look at the ages 65 and above, we exclude the first 65 ages. We start at age 0. That's why we can, the 65 indicates age 64. We sum those up and divide it by those at working ages 15 to 64. So 15, since we started age 0, it's value 16 through 65. I hope I made no mistake. So the old age dependency ratio is about 0.34. So there's 30, let's say, yeah, for each person at retirement age, there's about 3 people at working ages. I hope I have it correctly expressed. We have 100 people at working ages and about 30 pensioners. The change from 2006 to 2011, oops, not 2011, sorry, once again, my mistake, but that's what I have prepared. As you can see, Emacs lets you customize key commands very quickly, and so you can work without mouse, which is a major advantage. You see the old age dependency ratio increased already from 2006 until 2009. But what I think is very appealing is to look at the long-term age structure, because the current age structure is influenced by past birth and so on. But if we want to look at the effect of changes in fertility and changes in mortality, but only here now, changes in fertility, the old age structure, ergodic theorems and so on, that do not have any impact anymore on the age structure, which will eventually arise in the future, just looking at the time invariant fertility and mortality. So what will change? Let's do from now to stable. So the good news is, if you compare both values, the changes we have observed in fertility and mortality between 2006 and 2009 have actually an impact to reduce the number of pensioners in relation to the people at working ages. However, there's a difference, which is the other way around than in 2006 and 2009 if we look at the current age structure. But we have about 0.6, so we do not have 34 pensioners in relation to 100 people at working ages using this indicator, but more than 60, so 63 versus 62, more or less 61.8. But I thought this is especially appealing if we look at the effect of policies and look at the fertility and the other related measures, birth, or maybe the actual age structure 3, 4, 5 years later. This is mainly driven by the past experience, but not directly by the changes in fertility and mortality. That's why it's appealing to look at the long-term age structure of a stable population. What would happen if what we observe now continues indefinitely? How does it change the age structure in the long term? I looked already at the population momentum. And another policy question, looking now, if we think there is a need to increase the fertility rate, if our goal was to change the long-term growth rate, if it was possible to influence fertility via public policy, we have to assume that. And if the costs were identical at all ages, and if we look at proportional changes, so we can change age-specific fertility by 5% or 10%, or pick any number, so it's the same number. And you can pick one age where you would say, if we are able to increase fertility or decrease fertility, depending on the policy perspective, of course, at a single age, which one would have the biggest effect on the long-term growth rate? And we look again at Germany, 2006, 2009, or the slides I prepared are for the year 2011, but that doesn't matter too much. So who has a suggestion and wants to give me their reasoning? My students are also sometimes shy, but then I use the sample function from R, and then I just pick a random number and ask the person then for their ideas. Niklas is also part of the audience. I think he experienced this or suffered from it in the past. So who wants to give me an age? So proportional change, same costs at all ages. Which age would you select to change fertility? To change fertility with the impact on the long-term growth rate? Who dares to give an answer? It's more difficult than how many years does it take for the policy to take effect, because that's all answers are correct in that case, but the host maybe, Felipe?
Yeah,
Sorry.
otherwise you can type in the chat if you want to give an age, but my guess...
Is there something in the chat?
No. I said to them that they can type an age in the chat and then we can start from there. But I can say that I guess the earliest age possible. So Mia is with me saying that a younger age. So I would say like 15 to 16.
Like the answer for like the reproductive value and so on.
Yeah.
Well, I guess you can phrase the question or the answer in different dimensions. If we look at the reproductive value and saying how much does contribute to the future ancestry and so on, in the words of Fisher, the reproductive value would be probably a good answer. But then the issue is we looked at changes in fertility, not in mortality. And with a declining population, this would be age 0, I think, which has the highest value then. If we look at the reproductive value, but the age 15, that would be something reasonable. I thought something else, to look at the elasticity, to look at like how much eigenvalue elasticity. So if we look at changes in the long-term growth rate, that's the lambda here, given matrix, text BFA, yeah, that's a bit of misformatting LaTeX code. Looking at changes, how much is there a change in the long-term growth rate given we have changes in each entry, so rows I, columns J of our projection matrix. That's the definition given in Hal Caswell's matrix populations models book, without the LaTeX typo, of course. We can do this with our growth rate elasticity. So that would be Germany 06, growth rate elasticity. And what we obtain is many answers, many numbers. Of course, the 111 by 111 matrix, as many ages you have. But what we are interested in is the first row, because this gives the effect of changes in proportional changes in fertility. So what we can look at is, of course, we can do it differently, but can you see the figure?
Yes.
It's not a nice figure yet, but So let's limit our x-axis to 0 to 50. That's not nice. Ah, do you see the mistake? I picked column 1, not row 1. And here we have the results for the year 2006, showing the eigenvalue elasticity. So which ages for proportional changes in fertility would have the biggest impact on the long-term growth rate. And well, we can also ask which is the maximum. So that's the value 31. So that's age 30. AB line, we can make a vertical line at no, of course not, because we started at 1. And we can do the same thing for the year 2009. So you see, or you don't see, 2 lines, vertical lines, because they're identical. So if you were a policymaker and could pick a single age which should have the biggest impact on the long-term growth rate, it would be in this scenario, regardless whether we look at age 2006, year 2006 or year 2009, it would be age 30. I'm almost done actually with my presentation. I wanted to show you, if I have 2 or 3 more minutes. I also have this other code, this what I called World Pop Query. So if you're interested, not only in countries which are included in the human mortality and human fertility database, this is a very select set of countries of the world. If you want to use the world population prospects with 5 calendar years, 5 age years, you can do this as well. And the code is exactly the same. You just need some other arguments for the function, which is called a not stable pop HMD HFD, but stable pop United Nations. And you need to specify, as you can see down here, the country and the calendar periods over 5 calendar years. So I see on my select set of speaker or participants, Adriana Robles and Mia. Would someone of you want to pick a country just to show you how easily it is done?
South Korea.
South Korea, okay. So do you know the country code of South Korea, which the United Nations use? No, don't tell me you know this. That's why I wrote this super cool function called search country code. And you can, even partial matching is supported. Library, search country code, world pop query, no? No. Search country code. Now it works. Okay. So there's 2. Oops. There's two values for Korea. If I only look for Korea, so that's the Democratic People's Republic of Korea, so that's North Korea, and the other one is South Korea. So I call it example MIA, if this is okay. And then you simply say stable population, United Nations. Country is 410, and the period is 2005 to 2010. And that's it. You get exactly the same number of results, apart from the checking the fertility, the mean age of the fertility rates, because there's no value, but projection basic, projection momentum. Now, please don't forget that a value of 6.09 doesn't, of course, make sense for the generation lengths, but we have 5-year age categories. So if we look at example MIA, mu1 is 6.04 times 5. So we have a mean age in the stationary population for those years 2005, 2010 in South Korea of 30.23 and so on. So this brings me to the end of my presentation. You can have all the stuff sent to you, distributed by the organizers. I will still maybe find some more typos before I send it around, but I would like to thank you very much for your attention. I hope you had fun a little bit. That's number 3. I hope you saw that formal demography can be one tool, not the whole toolkit, but one tool to address policy questions. And I was also able, at least that's not a question mark, but a exclamation mark, to finally finish my software and present it here to the audience. Thank you very much for your attention.